Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field. All right, we're here in Scout Valley again, and we're going to deal with erosion and stream erosion. So we can see coming down, we've got a stream here. It comes up against this boulder, and then it makes almost a 90-degree turn and starts eroding out this bank behind me. And the creek looks really low right now. You know, it's maybe only 30 centimeters deep in the middle, but there's evidence in the creek bed that this creek rises up in the spring, and it'll have a lot more energy when it's deeper and a lot more input in the spring melt. And so that's when probably a lot of erosion happens on this bank behind me. As the river comes down and makes that 90-degree turn, all that energy is impacting that bank, and you can see it's undercutting the vegetation and eroding out and removing the smaller fragments, and it's leaving behind the bigger fragments, the boulders. They can't move that. There's not enough energy even in the spring with the snow melt and all that water, but it does erode out a lot of the fine material and slowly erodes back this cliff, and it's changing the course of this creek over time. All right, different perspective here on the creek bed. You can see it coming down to that boulder behind me there, and it takes a 90-degree. But what we can actually see in the riverbed here in front of me is we have the coarser sediment in the middle of the creek where we've got the concentrated flow. It's higher velocity, and so the fine sediments, the finer, the darker sediment here, it can't settle out over there where the energy is higher. The velocity of the water's higher, so it removes that fine sediment and leaves exposed the gravel and the coarse sand because the energy is not high enough to move it. But in the spring, this water level is going to be up here, and it's going to be able to move all that sediment along. But you can see the banks are quite muddy, finer grained, and the coarser grained in the higher energy channel. Now that higher energy channel is going to change depending on the flow. So right now it's concentrated there. As it goes down, they see the flow gets concentrated towards the right, and then in the spring, we're going to have high energy impacting straight on that bank and then making that sharp turn. And so the higher velocity water changes depending on the location in the creek or in the river. The same things, same concepts apply in a river. So it's really interesting that it scales up. We can look at this small creek here, and we can see the coarse sediment and the fine sediment, and that same concepts they apply in larger rivers. That's really cool. We're here on the shoreline of the lake, and we can see a lot when we dig down into the sediment that's been deposited on the beach here over time. We've got nice sand on the surface, and down further we've got gravel-sized pieces, even cobbles. They're so big I can't pick them out of here because they're stuck in the ground. But when I dug, that's the size of the cobble that I got out. Down further, just above the cobbles, we have some organics, some roots. All right, they've been plants growing. So the cobbles and the gravel at the bottom here will be a very stable shoreline for a time, because it would take a really big amount of energy to move a cobble like that. You can see this cobble, it's got a rounded side but also some angular pieces, but the gravel pieces more rounded, and the smaller the fragments, the better the rounding, because they've been washed about in the longshore drift current over time, and the smaller they are, the more movement they can undertake because there's less energy needed to move them. We've got sand at the top here that is being deposited by waves, but also we have ice in the wintertime. The ice gets pushed up onto the shore, so it's contributing to the movement of the sediments over time. We also get rain falling all across, and it also then will create a current as the slope is down towards the lake. So when it's raining, there'll be water moving across the surface here, creating some localized current, transporting very fine sediments across the beach. So on the shoreline, we've got lots of contributing factors, lots of energy, waves, ice, rain contributing to the deposition of sediment here on the beach. And we can learn a lot about the history just digging a hole here, playing in the sand. Once we've done all our learning, we can go jump in the lake.